Exercise 1.2 from chapter 1, that is real numbers. First question, prove that square root of 5 is irrational. For that, assume that root 5 is rational number. Express it in a by b form, that is square root of 5 is equal to a by b. Squaring on both sides gives that 5 is equal to a square by b square. Multiply on both sides by b square. This yields a square is equal to 5ab. From this equation, it is clear that a square is multiple of 5, which means a square is divisible by 5. Since 5 is prime number, if a square is divisible by 5, then a must also be divisible by 5. A is divisible by 5, we can write it as a is equal to 5c, where c is some integer. Substitute a is equal to 5c in equation 1. That we can written as 5c whole square is equal to 5b square. That is equal to 25c square is equal to 5b square. Divide both sides by 5. That is equal to 5c square is equal to b square, or b square is equal to 5c square. This equation shows that b square is a multiple of 5, which means a square is divisible by 5. Consequently, b must also be divisible by 5. From this, we conclude that a and b are divisible by 5, means shares a common factor of 5. Since it is contradictory to our initial assumption, that is square root of 5 is equal to rational number. So, square root of 5 is irrational. Second question, prove that 3 plus 2 square root of 5 is irrational. First, assume 3 plus 2 square root of 5 is equal to a by b, and assume this is rational number. Rearrange the equation to isolate square root of 5 on one side. This equation gives square root of 5 is equal to a minus 3b divided by 2b. And since a and b are integers, a minus 3b must also be an integer. Since b is a non-zero integer, 2b must also be non-zero integer. Because of the quotient of two integers, the rational number that is expressed in a minus 3b divided by 2 is rational. However, on the left hand side of the equation is root 5, which is irrational number. From this, we conclude that irrational number is equal to rational number. Since this is a direct contradiction, therefore initial assumption that 3 plus 2 into root 5 is irrational number must be false. Thus, 3 plus 2 into root 5 is irrational. Third question, prove that the following are irrationals. First one is the 1 divided by square root of 2 is irrational. Let us assume that 1 divided by square root of 2 is rational number. It can be written as 1 divided by root 2 is equal to a by b. Reciprocate both the sides. Root 2 is equal to b by a. Then multiply a on both sides. That is root 2 into a is equal to b. That can be written as b square is equal to 2a square. If b square divides 2, then b also divides by 2. And substitute b is equal to 2c in the equation. Then you get 2a square is equal to 4c square. That implies a square is equal to 2ac square. If a square divides by 2, then a divides 2. Hence, square root of 2 is not a rational number. Hence, 1 divided by square root of 2 is also not an rational number. Hence, 1 divided by square root of 2 is irrational. Next question. Prove that 7 into root 5 is irrational number. This is also proved with the help of the theorem. Let p be the prime number. If p divides a square, then p divides a, where a is a positive integer. Apply this theorem, we will get 7 into root 5 is irrational number. Next question is prove that 6 plus root 2 is irrational number. For this also use the same theorem. We will get the 6 plus root 2 is